All right, so today we are looking at factoring special cases. So you might recall from Unit 1 where we did some multiplying of special cases. And remember that factoring is the inverse or the opposite of multiplying or distribution. And so today we're going to look at the same special cases we saw in Unit 1, but now this time we're going to be looking at them in reverse, and we're going to be factoring them back to their factored form. So for today, your essential question is, how can you determine if a trinomial is a perfect square trinomial? So we saw something called the difference of squares back in Unit 1. And the difference of squares was 1 plus 1 minus. So we had 5x minus 2 times 5x plus 2. And in order for us to multiply this out, we would get f squared minus g squared. Now remember, f was the first term and g was the second term of each of the binomials. And with the 1 plus 1 minus, the signs are irrelevant because every time we multiply this out, we get the difference of squares, which means that we are subtracting. So we are going to have 5x to the second power minus 2 to the second power. So 5x to the second power is 5x times 5x, and that's going to give us 25x squared. So we have 5 times 5 and x times x minus 4. So again, every single time we have one binomial or the same two terms within each of the binomials, but one's plus, one's minus, it's going to multiply out every time to f squared minus g squared. Now with our binomial squared, when you have 5x plus 2 squared, that's going to give us a perfect square trinomial. So we're going to get f squared plus 2fg plus g squared here when we multiply this out. So let's go ahead and use the special pattern to multiply this out. Our f term is 5x and our g term is 2. So we plug those in. That's going to be 5x squared plus 2 times 5x times 2 plus 2 squared. And so when we simplify this, again, 5x squared is 5x times 5x, which gives us 25x squared. 2 times 5 is 10 times 2 is 20x plus 4. Now, I'm going to walk you through this, and I'm going to show you how to apply the special patterns to factoring. But keep in mind that we can still use the x and the factoring by grouping to factor both of these two polynomials here. So that's an option, but again, the pattern is just another method to using it. So it's totally up to you which method you choose to use. I will not require that you use the special patterns here, but I do want you guys to see them and know that they exist. So for our vocabulary, our first term is the difference of squares, which is what gives us 1 plus 1 minus. So that will look something like this. When you have a polynomial that is one perfect square minus another perfect square, that will factor down to f plus g times f minus g. So what we have to figure out is what number squared gives us this term and what number squared gives us this term. And again, that's always the subtraction because it's called the difference of squares. The binomial squared is what gives us that perfect square trinomial. So we want to check to see if we have that perfect square trinomial. And that pattern will factor down to f plus g squared. Now, if the 2fg term, if that middle term is subtracted, that's going to give us a negative within our factored form. All right, so let's take a look at some examples so you guys can see what they look like. So the first thing we want to do is just verify that we do in fact have a perfect square trinomial here. So we have to, again, identify our f and g terms. So what we want to figure out here is what number squared gives us 121x squared, and what number squared gives us 64. So the square root, or the number squared that gives us 121, is 11. And the number squared that gives us x squared is x. So 11x to the second power gives us 121x squared. Then what number squared gives us 64, or what is the square root of 64? That is 8. So from there, what we want to check to see is that this middle term fits the special pattern. So does 2 times f times g give us 176x? And that's what's going to determine whether or not this trinomial here is in fact a perfect square trinomial. So we test it. Does 2 times 11x times 8 give us 176x? So 22 times 8 does give us 176. So yes, this fits the special pattern, and therefore we can go ahead and just factor it down to look like this right here. So our f term is 11x. And this is addition. Our middle term is being added. Therefore, we use the addition symbol within our factored form. Our g term is 8. And our factored form is 11x plus 8 squared. Now, if you were to go through the process of using the x to factor this down, this is possible. Now, I know that these numbers are huge, but again, typically speaking, I'm not going to give you gigantic numbers like this. So using the x will be an option in the practice and on the tests and quizzes. So when we factor this down, what would happen when you factor by grouping is that you would get 11x plus 8 times 11x plus 8, which can then just be written as 11x plus 8 squared. So 11x plus 8 times 11x plus 8 is the same thing as 11x plus 8 squared. But again, you have to make sure that you check to see that your middle term does in fact fit that special pattern. Let's take a look at another one. So here, again, we need to identify if the first term and the last term are perfect squares. So what number squared gives us 196x squared? That would be 14x. What number squared gives us 9? That would be 3. We need to test that and see if this fits our special pattern. So does 2 times f times g. So 2 times 14x times 3. 2 times 14x times 3. Does that give us 84? And yes, it does. So from there, we can go ahead and apply the special pattern. And our binomial squared is what we'll get. Now here, we have to keep in mind that we have this negative in the middle. Therefore, when we put it in the binomial squared, we're now going to have subtraction. So our f term is 14x. Our g term is 3. 14x minus 3 squared is our factored form. Again, if we were to use the x to factor this and group, we would get 14x minus 3 times 14x minus 3, which can be rewritten as 14x minus 3 squared. So that is your perfect square trinomial. Next, we have the difference of squares pattern. And for the difference of squares pattern, again, there are a couple of things you have to check to make sure that it does in fact fit that pattern. So first, notice that there are only 2 terms. And second, you check to see that there is a minus sign in between them because, again, remember, this is the difference of squares. So here, again, and also with the first 2 GPs, we should be checking to make sure that there is not a GCF that we can take out. Again, that is the very first thing that we need to be checking for when we factor, anytime we factor. So if there is not, we can go ahead and check to see that we have a special pattern here. So first, yes, we do have a subtraction symbol. And then from there, we want to check to see, are these numbers perfect squares? What number to the second power would give us 144x squared? That would be 12x. And what number to the second power would give us 169? And that would be 13. So this is my F term, this is my G term. When we have the difference of squares, it will always factor down to be 1 plus 1 minus, one binomial with plus, one binomial with minus, with the same two terms inside of them. So that's going to be 12x plus 13 times 12x minus 13. Now remember, again, we can also use the x to factor this binomial here. Again, 144 times 169 is going to give us a really gigantic number. But remember what we said, when our b term is 0, we know that that number is a perfect square, and we can find those numbers because they have to be the same. So again, that is an option. Let's take a look at one more. First thing we need to check for is a GCF. Notice that both of these numbers are even. So I'm going to go ahead and divide out a 2. So when we divide out that 2, we're dividing each of these terms by 2. So that's going to give us 289x squared minus 25. Now, just like we did before, when we have that GCF out in front, we're going to forget about it until we get to our final answer, and it will appear out in front of our final answer. So from here, we're just looking to factor what's inside the parentheses. So we need to know what number to the second power equals 289x squared, and what number to the second power gives us 25. Again, we're looking for the square root of each of these numbers. The square root of 289 is 17, and we also have that x to give us x squared, and the square root of 25 is 5. We can now take that and plug it into the 1 plus 1 minus. So that's going to give us 17x plus 5 times 17x minus 5. And that 2, the GCF that we took out at the beginning, needs to appear out in front of our factored form. So those are our special patterns. Again, using the x is also an option here. I would like to see you guys attempt to use these special patterns, especially in the practice. And for now, all right, so now go ahead and pause the video and give these 2 questions here a try. I would like to have you guys use the special patterns just to try them out and see how you do with them. So go ahead and refer back to your special patterns and try factoring these 2 polynomials using the special patterns. All right, so for A, after you factor that down, you should get 10x plus 7 to the second power. And for part B, you should get 3 times 2x plus 5 times 2x minus 5. And that is factoring with special cases. Don't forget to have a toolbox, and don't forget to answer your essential question.